Okay guys, so for challenge number 9, you need to calculate the distance between two spots uh, located on the surface of the Earth. Actually, it can be on any sphere, but let's do it on the Earth. And this spot's location must be specified by the user using the latitude and the longitude uh, description for these points. So I guess you first of all need to understand what is the latitude and the longitude. So to understand this, we first of all we need to consider the Earth planet as an sphere. We know that it is not an sphere. It has a specific shape, but this specific shape it's going to make more difficult the calculations for the location of two spots. So for make it easy, we are going to consider that the Earth planet is an sphere. Yes? So this sphere can be divided by a line that cuts the Earth from the North Pole to the South Pole, and this line is called the prime meridian or the Greenwich meridian. You see, this line can cut the Earth planet in two perfect symmetric pieces. Yes, and also we can cut this sphere in two pieces by cutting it from the equator. You see this big line, and then you will have another two half Earth pieces. Yes, the important matter of this is that you can relate any point of the surface in the Earth planet by only giving two angles. Yes, you can relate the first angle from the phase that you get when you cut the Earth, dividing it using the prime meridian. Yes, and then this angle formed from the face of the cutted Earth planet to the point location, it's called the longitude of this point. Yes, and also if you use an angle related to the phase that you get when you cut the Earth by the equator to the point that you want to locate, then this angle is going to be called latitude. So as you can see, longitude and latitude are location quantities to specify the location of this and of any point over on the surface of the Earth. Yes, so these angles are the data that the user needs to insert. Now, to calculate the distance between two points specified by the longitude and the latitude of these points, we need to be able to solve these triangles. As you can see, we have this in here, the sphere, we have the P point and the Q point, and so each of these points has a longitude specified by He1 and He2. Yes, and also these points has a latitude specified by Phi1 and Phi2. Yes, so this is the data that the user needs to insert into your app. Now, we need to solve these triangles to calculate the value of the angle formed by these two lines, and we need to calculate this angle because the distance from one point to another point running over the sphere is related with this angle. So first of all, we need to solve these triangles, and to solve these triangles we need some mathematical background from trigonometric. So the solution is given by this cosine law of great circle or great circle distance if you want to look for information. This is the solution. So this angle, it's equals to all of this. So this is the arc cosine function, and you have sine function and cosine function. We also have a delta he, that is the difference between he2 and he1. So you only need to subtract he1 from he2 to get this value. So all these functions are available on the App Inventor. Now we need to understand how this angle is related to the distance of these 2 points. So for this I need to show you something more. And what I need you to understand is that when you have two lines like this, and these lines pass through the center of the sphere, like in this case, you can create a plane formed by these two lines, something like this. You see? And then, you see, these two lines form a plane. Yeah? And if you cut this sphere using this plane, like this, you see, you have half a sphere, and then the face of the cutted sphere always it's going to be a circle, and the diameter of this circle it's the same diameter of the whole sphere. Yes? So for any two lines that cut the sphere from the center, you always are going to have the same circle face. And then, because the diameter is always the same, the perimeter is always the same. So you can relate the angle formed by these two lines to the perimeter of the circle, and therefore you can calculate the distance between this point and this point. So as I told you before, if you have two lines passing through the center of the sphere, you can cut this sphere into a circle, and then you can relate the angle formed by these two lines with the distance between 2 points on the surface of the sphere. Yes? So the relationship depends on the perimeter of the circle. Yes? And of course of the angle of the formed by these two lines. So let's consider that we are working with the Earth, right? And the full circumference is of course 316 degrees. Yes? And this corresponds to more or less 40,000 I guess kilometers. You can check this data, but it is more or less like this. Yes, I guess it's 40,000 kilometers. Yes. So if this angle, let's say it's 90 degrees, well, you can have a proper relationship. Yes. So this is a quarter of this, so you will have a quarter of the full perimeter of the Earth, and then you will have 10,000. Yeah? Of course, if you have another, and then this is the distance between these 2 points, this point and this point, and it corresponds to this section of the arc. Yes? So it is related with the angle of this formed by these two lines, and then you can have the relationship. Of course, if you have another value, I don't know, maybe 35, degrees, so you can multiply 35 by 4,000 kilometers and then divide it by 316 degrees, and then you will have the proper value. So this is the way to relate the angle formed by the lines that points to the locations from your app with the distance around the Earth, in this case, from this point to this second point. So I guess with this is enough for you to finish your activity, and if you have any question you can always ask to me.